Education is key, and we welcome you with open doors in Shifaa Online TV. My name is Dalila Hamza. Today we have a physics lesson with Mr. Muhammad, who's going to take us through all that. Remember, the program online is sponsored by Shifaa Muslim Youth Initiative in conjunction with Shifaa Online TV, with Radio Salam Kenya and the Office of the Senate of Mombasa, Mohammed Faki. Let's get started.
Welcome on board. Morning, everyone. As it was introduced earlier, today we are having physics. And we are still on the topic of mechanics. In our earlier session, we had introduced the lesson or the session by defining some terms such as what's displacement, velocity, and acceleration. And even we went further into the derivation of the equations of motion, or the kinematic equations. But for the interest of those who are not with us, I'll try to review on the equations of motion a bit. These equations are derived from the definition of acceleration, whereby we know acceleration is equal to final velocity minus initial velocity. The first one is v, we use it for final velocity, and the second one is u for initial velocity. So from this, we derive the kinematic equation or equations of motion, whereby the first one, when we have it, we get AT is equal to V minus U. Making V the subject, we get V is equal to U plus AT. This becomes our first kinematic equation. Then the second one, from the definition of velocity, whereby we have displacement times displacement over time, we get that S, whereby we use S for representation of displacement, is equal to average velocity times time. So average velocity, we take that it will be a half multiplied by initial velocity plus final velocity times time. But from our first equation, we know that V is equal to U plus AT. So replacing V with U, we get a half into bracket U plus AT times T. So when we add, we get 2U plus AT. When we multiply by the outside, we'll get S is equal to UT plus a half AT. A half AT, and this becomes our second kinematic equation. This one will be ut plus a half at square, whereby a is acceleration. So we can go to the third one. From the equation of acceleration, when we make t the subject, we'll have t is equal to v minus u over a. So our s, which is equal to average velocity times t will be equivalent to v plus u, or u plus v, over 2 multiplied by the representation of t, which is equal to v minus u over a, which is acceleration. When we multiply from the algebraic identities, we know the difference of two squares. It will be s is equal to v squared minus u. Okay, we can multiply through, so you'll see how it comes about. It will be v squared plus v squared minus v u plus u v minus u squared over 2a. So these two will cancel out each other. Then we'll remain with s is equal to v squared minus u squared over 2a. So our third, when we make v squared the subject, we'll have v squared is equal to u squared plus 2as. So our third equation of motion, or kinematic equation, becomes v squared is equal to u squared plus 2as. Can go through an equation and we see how these equations are used. According to the information you are given in a question, you have the flexibility of choosing the most appropriate equation. we're asked we're told that a car moving with a velocity with a velocity of 15 meter per second, 15 meter per second, accelerates uniformly at the rate of 2 meter per second squared to reach a velocity of 20 meter per second. So you are asked to find 1, time taken, and 2, the distance traveled Okay, we're told a car moving with a velocity of 15 meter per second accelerates uniformly. Our key point here is accelerate. It is a positive acceleration uniformly at the rate of 2 meter per second square to reach a velocity of 20 meter per second. So in a physics problem, it's very important that in one of the skills which you have to apply is a 4-step skill whereby first you have to visualize. Are you able to draw a picture or a sketch of the problem? So we have point A and let's say point B, whereby at the beginning the car is at 15 meter per second, which is our initial velocity. Then it accelerates at the rate of 2 meter per second squared to reach a velocity of 20 meter per second. So we are asked, first we are asked what is the time, and second we are asked what's the distance. So first we start with the time. We have visualized. Then we go to the concept. Are you able to conceptualize with the given equations of motion, which one do you think is more applicable? You have initial velocity, acceleration, and final velocity. And the first one you are asked time. So we can use the first equation. U is equal to 15 meter per second acceleration is equal to 2 meter per second squared, and final velocity is equal to 20 meter per second, and we are asked time, which we don't know, but we know final velocity. The first equation of motion says that final velocity is equal to initial velocity plus acceleration times time. So we can insert the values into the equation and we solve for the unknown, which is time. So we see that 20 meter per second is equal to initial velocity, which is 15 meter per second, plus acceleration, which is 2 meter per second square times time. So we'll collect the like terms together. We'll have that it will be 20 minus 15 into bracket, which will be meter per second, is equal to 2 meter per second squared times t. So why am I including the SI unit? To avoid that you have reached the final answer and you just put units which you don't know where they came from. So we'll find that we'll get 5 meter per second squared when divided by 2 meter per second squared, we'll get t. So the meter per second and meter per second will remain with only one unit, which is second. And we'll get that our time t is equal to 2.5 seconds. That's our time. Okay, in the second section, the distance traveled. We have get our time, but we need the distance traveled. So we can either choose equation 2 or equation 3, and all will give us the same answer. So let's say when we go with equation 2, what do we get? We are given that S, or displacement, is equal to initial velocity times time plus a half times acceleration times time squared. We have our time now is 2.5 seconds. So inserting the values in the equation, our initial velocity is 15 meter per second multiplied by the time, which is 2.5 seconds, plus a half times acceleration, which is 2 meter per second squared, 2 meter per second square times the time, whereby 2.5 is the same as 5 over 2 squared, will be 25 over 4. 25 over 4, and the unit will be second squared. So we'll find out that the signs will cancel out. The second and the second will cancel out. We'll remain with, on this side we can also put 5/2 for simplicity, 5/2 seconds. So when we multiply, we'll get 75/2, which will be meters, plus the 2 and the 2 will cancel out, will remain 25/4. And also this here, the unit will be in meters. So when we do the addition, we'll find that here we'll get 150. When we add, (150) plus 25, which is equal to 175/4, equivalent to 43.775 meters. Let's look into the third equation. If it will also give us, we have get that our S is 43.75 meters. Let's look the third equation and see if it also gives us the same answer. Final velocity squared is equal to initial velocity squared plus 2 times acceleration times displacement. So when 20 squared, it will be 400 meter squared per second squared is equal to 225 meter squared per second squared plus 2 times acceleration, it will be 2 times 2 meter per second squared times S, which we don't know. So we can bring 225 to the other side since it has the same units with 400. So we get 400 minus 225, whereby the unit will be meter squared per second squared is equal to 4 meter per second squared times S, or displacement. So after subtracting, we'll get 175. Then it will be meter squared per second squared divided by 4 meter per second squared is equal to S. So the units, you'll see that they'll cancel out and will remain with one unit for length, which is meters. So when we divide, we get that displacement is equal to 43.75 meter. Okay, let's go through to the application of the kinematic equation of motion. Okay, in the motion under the gravity, we are told that when an object falls to the ground under gravitational pull, experiments show that the object has a constant or uniform acceleration of about 9.8 meter per second squared or 10 meter per second squared approximately while it's falling. So we are told that if this is an object and it happens to go towards the ground, we have an uniform acceleration which is called, denoted by G for gravitational pull, which is 9.8 meter per second squared or approximately 10 meter per second squared. So we are told that when an object falls toward the ground, it experiences, or experimentally it has been shown that it undergoes a gravitational pull, which is a gravitational acceleration, which is denoted by G, which is it is 9.8 meter per second squared or 10 meter per second squared approximately. So the thing is, so in our kinematic equations, we'll have now to substitute the value of A acceleration with G. Then our kinematic equations will be when working on a question to do with gravitational we have to put more emphasis that when an object is moving toward the gravitational pull, the gravitational constant is positive. But when thrown upward, it has to be negative because we are moving against the gravity. Let's look into an example. Okay. We are asked that suppose that a ball is dropped from a height 20 meters above the ground, then the initial velocity u is equal to 0, and the acceleration a, which is equal to g, because it's going toward the gravity, is approximately 10 meters per second squared. When does the ball reaches the ground? So first we have to do a visualization, or we try to draw a sketch. Can rub. We have a height 20 meters, and here it is a ball, so it's dropped vertically downward. So we are asked, here we are told when the time it's being dropped, initial velocity is equal to 0, because at that time it's momentarily at rest. So we are asked, at what time does the ball reach the ground? So from the kinematic equation, we have the height, which is the displacement. We have the initial velocity, and we are asked, we have also the gravitational pull, which we are being told to use 10 meters per second. So we have that S is equal to 20 meters, G is equal to 10 meters per second squared, U is equal to 0 meter per second. So with the kinematic equation, we can use the second equation, which says that displacement is equal to initial velocity times time plus a half gt squared. You have to see why is it positive? Because it's moving toward the ground. When we insert the values, we'll have that 20 meters equals to initial velocity, which is 0 times t. So it will be 0 times t, which is the same as 0, plus a half times g, which is 10 meters per second squared, times time. Then 20 meters is equal to, we'll have 5 meters per second squared. So when we divide both sides by 5 meters per second squared, we have t squared here, t squared. So we'll get that 4 seconds squared is equal to t squared. When we do the square root, we'll find that 2 seconds is equivalent to time. So it will take 2 minutes to fall to the ground. We can go to our second example, whereby we're told that a ball is thrown. A ball is thrown upward, vertically upward, upward with an initial velocity of 30 meter per second. Find 1, the time taken to reach its highest peak. Its highest point, sorry. Second, the distance traveled. So we are told that a ball is thrown vertically upward with initial velocity of 30 meters per second. Find the time taken to reach its highest point, then the distance, then traveled. So first of all, we identify the given information. We have initial velocity, 30 meters per second. We have our g, which is 10 meters per second squared. Then we can visualize this is the distance s. A ball is thrown upward, vertically upward. Initial velocity u, 30 meters per second. We have to note that when the ball reaches the highest peak, its final velocity will be 0 because it will be momentarily at rest before it starts going back downward. So our final velocity v will be equal to 0. And also we have to note that since it is going against gravity, our acceleration will be equal to minus g because it's going against the acceleration. So our kinematic equation which we'll use will be v is equal to u minus gt. So we'll see that our equation has a negative sign because the object is moving against the gravity. By inserting the values, we'll find that our final velocity 0 is equal to 30 meters per second minus 10 meters per second squared times t. We can take 10 to the other side, whereby we'll have 10 meters per second squared times t is equal to 30 meters per second. We divide both sides by 10 meters per second squared, whereby we'll have that t is equal to 30 per second over 10 meter per second squared. When you divide it through, we'll get that time t is equal to 3 seconds. Then to the second part, distance is equal to ut minus a half gt squared. We have our time and we have our initial velocity, so you're only going to, so displacement is equal to 30 meter per second times 3 seconds minus a half times 10 meter per second squared times 3 squared, which will be 9 squared. 9 and the unit for time, which is seconds, we square it. So here we'll be left with 90 meters minus, when we multiply, you will get 2, here is 10, 9 times 5, we get 45. So our distance is 45 meters. Okay, I'll leave you with 2 questions as an exercise. So the questions are, a ball is thrown vertically upward with an initial velocity of 20 meters per second. Calculate the time taken to return. The time taken to return to the thrower. Second, the maximum height reached. Then the second question, a ball is dropped from a height of 20 meters and rebounds with a velocity which is 3/4 of the velocity with which it hits the ground. What is the interval between the first and the second bounces? Thank you. I hope you enjoyed the class. You tried the question, and if possible, we'll try and to recap them in our next session.
This is between me and you. I enjoyed the class very much. Remember that we're going to take a short break, but we'll be right back with social status as Mr. Bashir digs up the tricks and turns of making your excellency in education to another level. Let's meet again.